Hi, everyone. I hope you're having a great day. We're going to talk about solving radical equations today. First thing we have to look at is what is a radical equation? Well, a radical equation is where the variable is the radicand. In other words, the variable is underneath the radical. So these first questions ask, which one of these are radical equations? Where is my variable at in this first example? Yeah, it's underneath my radical. That means that this is then a radical equation. Looking at the next one, where is my variable at? My variable is underneath the radical. This time it's a cube root. So once I see that my variable is underneath, I know it's a radical equation. Looking at the last one, where is my variable at? My variable is here. This just says the square root of 5. The square root of 5 is a real number. This is just the exact value, so we leave it as a radical. So this last one right here, is not a radical equation. All right, so let's talk about our power rule. Our power rule says if x equals y, then x raised to some power is going to equal y raised to some power. But you do have to make sure that you check your solutions. Make sure that you know what the domain is and what actually works when you plug it in. So we're going to be doing our solving, but we're also going to practice plugging our answers into our calculator. That way you can check your answers when it comes time for the test. All right. First thing we're going to learn how to do is solve the radical equation with one radical. So it says isolate the radical. Well, imagine that you're trying to find or solve for a variable. So let's look at A. I'm trying to solve for x. Well, where is x at? X is underneath the radical. So what do I have to do? I have to get that radical by itself. Just like if it was x by itself, I would need to get that by itself. So what do I have to do to get this radical then by itself? Yeah, subtract 2 from both sides. So whatever I'm doing to one side, I'm doing the same thing to the other side. So now I have the square root of 3x is equal to 5. Now, where is that variable at? It's underneath that radical. I want to get rid of that radical. So in the previous step, we had to subtract 2 from both sides. Whatever we do to one side, we have to do the same thing to the other side. This says, number 2 up here says, raise both sides of the equation to the power of the index. What is my index here? It's a 2 when it's not written there. But think about the fact that I want to get to what's inside the radical, so I need to get rid of my radical. I need the inverse operation. So how can I unsquare root something? Yeah, I want to square it. That's the opposite operation. That's gonna get rid of that for me. But whatever I do to one side, I have to do the same thing to the other side. So now I have 3x is equal to 25. Divide both sides by 3. X then equals 25 thirds. So now we're going to check our answer. So here, the square root, you go back up to your original. So I have that 3 there times x. I'm going to plug something in for my x. So I'm going to open my parentheses. I'm going to hit my fraction. Now I'm going to say 25, then divided by 3. I'm going to hit that right arrow key because I want to close those parentheses. But now I don't want to stay underneath the radical anymore. So I want to hit the right arrow key again and then say plus 2. So do you see how that plus 2 is not underneath the radical? That's what we're looking for. All right. Now let's look at B. B says the cubed root of 5 plus 2n minus 3 equals 1. So where's my variable at? Here's my variable. It's underneath that radical. So I need to get this radical by itself. How do I get that radical by itself? Add 3 to both sides. So now I have the cubed root of 5 plus 2n is equal to 4. Now my radical is by itself. I want to cancel out that radical, which means I need the opposite operation. So what's my opposite operation going to be? Yeah, raising it to the third power. Whatever you do to one side, you do the same thing to the other side. So now I have 5 plus 2n is equal to 4 to the third is 64. Now solve. Subtract 5 from both sides. So I have 2n is equal to 59. Divide both sides by 2. So now n is equal to 59 halves. So now I want to check my answer. Can I still check my answer with a cube root? Absolutely. So here I'm looking at what my original is. So I'm going to go ahead and say cubed root. And then underneath there, I have 5 plus 2. I'm going to plug something in. And once again, it's a fraction. 59 divided by 2. Close that. And now I want to go outside my radical. So I'm going to hit that right arrow key again and then say minus 3. When I press enter, I get 1, and that's what my original equation says. All right, let's look at E. So looking at E, I'm going to go through my steps here. I need to isolate my radical. What do I have to do to isolate my radical? Subtract 12 from both sides. So now I have the square root of 6x minus 1 equals negative 5. Now I want to unsquare it. How can I unsquare it? Yeah, square both sides to make sure you square both sides. Now I have 6x minus 1 is equal to 25. Solve. Add 1 to both sides. 6x equals 26. Divide both sides by 6. I get x is equal to 13 thirds. All right, so 13 thirds. Let's check our solution. So 6 times, oh, it's all underneath the radical, so I want to make sure it looks exactly like that every time. So 6, open my parentheses. Anytime you write your answer as if it's a fraction, you need to make sure that it's in reduced form. So that's why I did that. So 13 divided by 3. Nope. 13 divided by 3. And then minus 1. So that's underneath my radical. Then I'm going to hit plus 12. Does that equal 7? Nope. It equals 17. So that didn't work. So in this case, my answer is then no solution. So I'm going to cross that out and say no solution. Now, the reason why it's no solution is actually right here. I could actually stop right there and say, I know it's not going to work. Why is it not going to work? Because I have the positive square root of 6x minus 1 equals negative 5. Here, the sign that's in front here is a positive. My sign that's in front here is a negative. it's not going to work. No matter what you try to, you go through all the steps, you seem like you have the correct solution, it's not going to work. All right, let's look at F. So with F, this time I have a radical on both sides. So we don't have the directions for this, but it's the same thing. If I have a radical on both sides, I'm actually, are both of my radicals isolated? Yep. So cube both sides, doing that opposite operation. So I have x plus 9 is equal to 5x plus 1. Solve here. So I'm going to go ahead and subtract x from both sides. So I have 9 is equal to 4x plus 1. Then subtract 1 from both sides. And then I have 8 is equal to 4x. Divide both sides by 4. And then I get x equals 2. So now I'm going to check my solution. Checking my solution. I have the cubed root of 2 plus 9. Enter. And then the cubed root of 5 times 2, and then plus 1. I get the same thing on both sides. See, so it's really, it's not terrible to check your solutions on your calculator. That's the only calculator you have to use during the test. So practice with your homework using it. So here's just another example. This is just a literal equation. There's a misprint right here because it says solve for R. It's already solved for R, so we're going to solve it for A. So here, I want to solve for A. Where is my A at? It's underneath my radical, so therefore I'm going to go ahead and square both sides. So now I have R squared is equal to A divided by 4 pi. I want to get that A by itself. Well, right now it's being divided by 4 pi. So what's my opposite operation? What's the opposite operation of division? Multiplication. So I'm going to multiply by 4 pi, which means I multiply this side by 4 pi. So then I have A is equal to 4 pi R squared. So that's solving that equation for A. All right, let's look at a couple word questions here. On Earth, if an object is dropped from a height of h feet, the time in seconds it will take to reach the ground is found by using the formula. A construction worker dropped a hammer while building the Grand Canyon Skywalk, 4,000 feet above the Colorado River. Find how many seconds it took for the hammer to reach the river. So the time in seconds it will take to reach. So T is my time. Going back here, time is my T. And then my height is my H. It's just labeling the different things. So now this question asks me to find how many seconds. So I know I'm looking for T. So now I have T is equal to 4,000 feet. So I have the square root of 4,000 divided by 4. Taking my calculator, the square root of 4,000, enter, divided by 4. Oh, shoot. Okay. I mean to do that. All right, so the square root of 4,000, enter. Then I want answer divided by 4. That's how you plug that in like that. Can you do it in one step? Absolutely, you can also do it in one step. So how many seconds did it take for the hammer to reach the river? It was 15.8 seconds for hammer to reach river. If an object takes 8.5 seconds to hit the ground, what was the height of the object when it dropped? Okay, so here I'm looking for the height. So this time I know I'm looking for h is equal to. What's given to me is my 8.5 seconds. So 8.5 is equal to the square root of h divided by 4. So now I need to solve, which means I need to get my radical by itself first. Well, what's happening to my radical? So here's my square root of h. It's being divided by 4. So what's my inverse operation there? Yeah, again, multiplication. So I'm going to multiply both sides by 4. So now I have the square root of h is equal to 4 times 8.5, and I get 34. But I still have to solve for h. Right now I have the square root of h is equal to 34. So I want to unsquare my h. So what do I have to do to both sides? Square it. So then 34 squared, I get 1156 is my height. So what was the height of the object when dropped? The height of the object was 1,156 feet. If the length of the skid marks is d feet, then the speed s of the car before the brakes applied can be found by using the formula. So here I have my s is my speed and my d is the feet of the skid marks. So now it says an accident investigator measured the skid marks of one of the vehicles involved in the accident. The length of the skid marks was 175 feet. So that right there is my D. Find the speed. So S is equal to before the brakes were applied. So here I have S is equal to the square root of 24 divided by 175. So 24 times 175. So say I wanted to do that first. So I have S is equal to the square root of 4,200. Then I want to take the square root of that answer. And I get S is approximately, rounding my answer to the nearest tenth, it says, is 64.8 is my speed. And I would think that would probably be miles per hour. So the speed of the car before the brakes was 64.8, and I'm assuming miles per hour. Well, I hope that helps. Have a great day and good luck on your homework.